All right, so we are starting chapter 4, and this is section 1 for IM1. Sorry, I'm arranging my screen here really quick. Graphing equations in slope-intercept form. So in the last couple of sections, we were talking about arithmetic sequences within linear functions and how to write an equation using an arithmetic sequence. So we ended up having to plug it in to that equation, which looks like an equals a1 plus n minus 1 times d. So this is our first term in our sequence. This is the number term we're looking for. This is our common difference. So there's a lot of pieces that we have to know in order to plug it into this one. So now what we're going to learn is how to use some of the pieces of a linear function that are a little easier to find when we're looking at a line and we're looking at even coordinates. And I'm going to mess with this screen just a little bit more. I wanted this to be scooted up just a little bit so we can kind of see the whole graphic here. So this is definitely a very bubbly page. It's meant to be colored in, so you're welcome to get very artsy with this one. I kind of like doodling and all that on here, so I thought this was kind of a fun page. So we're going to go through and fill in these top two corners here. So it says the slope is, and that's the rate of change. Change. Right? Or we can think of it as rise over run. It's kind of a easy way to think of the slope. A y-intercept is the point where the line crosses the y-axis. Okay, so it's just the point where we cross that y-axis. Remember, that's the axis going straight up and down. So we have this very big lettering here, slope-intercept form. So it's pretty obviously named. We're going to have a slope and we're going to have an intercept, specifically a y-intercept. And there's a form of a line for this. So over here it says a formula for the equation of a line using the slope and its y-intercept. So same thing I just said out loud. All right, so here is the equation. Y equals mx plus b. M is our slope. And b represents the y-intercept. Y-intercept. Spelling that funny. Go back. Intercept. There we go. And a big thing on this one is it is the starting point. Starting point. So especially, and I keep saying this whenever I go over this in any of my math classes, because once we start getting to word problems and we're using this, it's important to remember that the y-intercept is where you're starting. And then the slope is where you're changing from there. You're going up and down from that point, from the y-intercept, from the starting point. So this is the change, so vertical and horizontal change from this starting point. Okay, so that's the idea of these ones. So we have our y variable and our x variable. And once we have the slope and the point, we can plug in different pieces to manipulate to see when I have 1 for x, what do I get for y? Because it says y equals mx plus b, we don't usually plug in y because then we're going to have to go through and do more operations to get x by itself. So a lot of the time we end up plugging in x, which is our input, and we get y back out. All right, let's go ahead and go to the next, or the bottom part of your page. So we're going to just do a couple of things here. So this is the steps for graphing an equation. So first, remember that it is, and I think I put this, oh, it's down here. Sorry, I was trying to look for it. It was on a slightly different place on my teacher notes. So graphing, we're going to try graphing the line y equals negative 3x plus 2. So here's what we're graphing. So step number 1, start by placing a point at the y-intercept. Remember, that is our starting point. Okay, so in a word problem, we're looking for the starting point, but also this is what we start with when we start graphing. So y-intercept, remember it's y equals mx plus b. B is our y-intercept. This is our starting point. So the b. Okay, so positive 2. So I go from the center and I go 1, 2, and there it is. And then the second thing is from that point, meaning the y-intercept, count out to find the next point. So we're going to be using the slope to count out. So this says be careful about positive and negative directions. Positive and negative. So sorry, that fits a little nicer when I'm typing, but so it's just a warning, be careful about positives and negatives, and I can even clean this up a little bit and go positive or negative. Okay, so just be careful about positive or negative. It is positive or negative. I don't know if that even helps, but just so you know that it's positive or negative and not like a T. All right, so we're going to count out our slope. So our slope is the m. So it's negative 3. So remember, this is our m, and this is negative 3 over 1. If I don't see anything underneath it, it's over 1. So negative 3 means I go down 3. So from my starting point, I go 1, 2, 3. And since it's positive 1, I go right 1. And if you didn't have room to go up or down the amount of distance you needed to, you could actually move that negative down to the bottom if you needed to. And I could say, well, I'm going to go up 3 and left 1. That would also work because we can see that's going to be in a nice kind of straight line there still. Okay, so it's just an option. You can do that. All right, now we have our second point. We really only need 2 points to do this. The third point is to connect. We want to connect those 2 points so that we have a line. And I'm going to use my line tool here. I go 1, 2, 3, over 1. Okay, I wanted to make sure that I was doing that nicely. Boom. And I can also connect it up this way. Boom. So you won't have to do that double connection. You'll be able to just click, and it'll snap like that on Alex. You won't have to kind of play with it a little bit like I just did because mine doesn't snap a real line for me. It just goes from point to point. So I had to kind of cheat it a little bit, but there's my line. So first y-intercept, then use your slope to figure out the change in y over the change in x, and then we connect. All right, slope-intercept form, so we just give it to you again right here. It's just a reminder. So start with the y-intercept, use the slope to graph from the y-intercept, and then connect your points. So it's just that same notes page, just kind of condensed for you. So we're going to write an equation of the line in slope-intercept form, given the slope and the y-intercept. So if we're given the slope and the y-intercept, remember it's y equals mx plus b. M is the slope. Slope is m. So m is going to go in here, m, right? Instead of m, I'm going to go ahead and insert the negative 1/2. I know what it is. And then b is your y-intercept. So remember it's plus b, but I'm replacing that with 3. All right, so now we can go ahead and work it out. So this is our equation. I said work it out. We did work it out. I'm just being silly. This is the equation that they would want you to type into Alex. Then it says graph the equation. So remember, I'm going to start at my y-intercept. This is my starting point. Start at 3. So I'm going to go 1, 2, 3. There, I'm starting. Then I'm going to use this. So then use the slope. So you can write that out if you want to, but I'm just saying then do this. Okay, so negative 1 and positive 2. And I can do that more than once if I want more than 1 point to kind of make sure. 1, 1, 2. I can even do it this direction. I can go up 1 and left 2. So just remember to do the opposite. I went down 1, right 2. If I go up 1, I have to go left 2. And we can see that's going to make a nice straight line there. So now, if I connect these guys, let's see, we'll connect it with a bright green. Up 1 over 2, so it would be right there. I'm just trying to do this kind of nicely. There we go. So I've connected my line. And it would go on and on forever in both directions unless we were given some kind of limit. Okay, the next piece says graph each equation. So if we want to graph this equation, we can go back to what we were doing before where we had x and y intercepts. Or we could kind of manipulate it into being slope-intercept form. Either way, it works out kind of the same idea. One is not really less work than the other, so it just depends on which method you like better. So before, what we did was we found the x-intercept by making y 0. So we went 3x minus 4 times 0 equals 12. And then, and this is parentheses, sorry, 3x, 4 times 0 is 0, so this just kind of falls away, and we have 12. And then we divide by 3, because I'm multiplying by 3 here. So that gives me x equals 12. So now I can graph that right on here. I could say it's 12 if I wanted to do the x-intercept. The problem with that is I don't really have 12 on here. It doesn't go out that far. This graph is much smaller. So this is going to be very difficult to use unless I change the graph or if I get a new graph. Now, the one on Alex will be a little bigger than this. This one is smaller because I know when I made this one or when we made it, we were specifically looking at doing this type of equation. So that's the only problem. I wanted to show you that it's a little big as far as graphing this, unless I go 2, 4, 6, 8, 10, but even then I'd end up having to be off my graph. I counted by 2s. So I'm going to back up a little bit, and we're going to solve this for y, okay, so that we can actually get some numbers that we can graph on this smaller piece here. So we need to get y by itself. I'm going to start moving the pieces that are being added or subtracted. Be careful, this is a negative, but it belongs to the 4. Okay, this is actually a positive 3, that's why I'm subtracting 3x. So 3x minus 3x cancels, 4y equals negative 3x plus 12. I put the 3x in front so that it looks like y equals mx plus b. So it's already in slightly this format. All we have to do is divide by 4 because I want to move this, or negative 4. I want to move this to the other side here, like this. So negative 4 divided by negative 4 cancels. Remember, this is just like distribution with multiplication, but it's division. I have to divide both things. So it's negative 3 divided by negative 4, which just turns into positive 3/4 x. It's being multiplied. And then this is positive 12 divided by negative 4, which is negative 3. So both things were divided by 4, not just one of them. So really, I didn't do too much extra work from what I did when I was trying to make y 0 and find my x-intercept. And I'm already at y equals mx plus b. So now I just need to identify my starting point. So here's my b. That's my starting point. I'm going to go down to 3. 1, 2, 3. And then my slope. This is my slope, right? So I'm going to go up 3 and right 4. 1, 2, 3, 1, 2, 3, 4. And there we go. I've got my 2 points, and I can go ahead and graph this line. So let's see, I'm going to go through here. And see if I can line this up nicely. There we go. So I've graphed my line using y equals mx plus b. Alrighty, I believe... Do we have another one? Oh, okay, we do have one more page. I thought we were all done with that section. Alright, so one more page, and then we'll be all done. So, graph each equation. Whenever I'm given y equals a number or x equals a number, either way, it's going to be either a vertical or a horizontal line depending on what I'm given. So it might actually be counterintuitive, or I think, to what students think. So when they hear y equals 5, well, y-axis is straight up and down. It's a vertical line. So this is going to be a vertical line, right? Not necessarily. What it means is y is always 5. So if I go 1, 2, 3, 4, 5, well, in order for y to always be 5, it actually has to be on this line like this. So when I hear y equals a number, it's going to be a horizontal line on that number. If I hear x equals a number, it's going to be a vertical line on that number. So it's just something to keep in mind. It's kind of opposite what you might think. Just because it says y equals does not make it a vertical line. It actually makes it a horizontal line. Because now, no matter where I go, if I come over here, I have to go up to 5 to get to y. If I come over to the right, I have to go up to 5 to get to this line. So it just means that the line is always up on the 5 for y. All right, let's look at this last piece here. We have the band boosters are selling sandwiches for $5 each. They bought $1,160 in ingredients. And we need to do 2 things. It was asking for 3 things. I'll talk about why B is crossed off in just a moment. And I can even show kind of a graphic for it. But it's a little bit difficult to graph numbers this big and have the scale be kind of nice looking. So first we're going to write an equation for the profit, P, made on N sandwiches. Now remember, if it tells you to use P for profit and N for sandwiches, and you decide to use different variables on Alex, on our online program, it will mark you wrong. You might have used the right numbers, and the letters might be in the right place, so the variables might all be in, the correct positions and be multiplied or added or subtracted in the right way, but you're not using the correct ones. So really, it's dinging you on not following directions. So just don't be picky. If it says use P for profit and N for sandwiches, go ahead and follow those directions. All right, so let's think about y equals mx plus b again. Remember, b, our y-intercept, is our starting point. So we're starting at negative 1,160. The reason we're starting there is because this is at the very beginning, before we've sold anything, we're down this much money. They bought this much money worth of ingredients, right? So our starting point is negative 1,160. The change, so remember that's our slope. What are we changing by? Would be $5. Anytime I'm looking for words like each, that tells me that there's some kind of change there. Okay. So $5 each for sandwiches. So that's going to be my change. M. And N is the number of sandwiches. They don't want me to use X. They want me to use N. So I'm switching that variable out just so I match up with my directions here. So $5 per sandwich. And this tells me how much I'm making. To know profit, though, I have to subtract what I've spent. Okay? And instead of Y, they want us to use a capital P there for profit. So that's a basic formula there for profit. If I calculate what I've made, so what have I sold so far, and I have to subtract what I spent to begin with. That tells me what my profit is. Okay? So here is our equation. We have already built an equation. Happy day. So now we need to find the total profit if 1,400 sandwiches are sold. So we want to know what P equals when N, or the number of sandwiches, is 1,400. So we have 1,400 in here, and I'm using parentheses for multiplication. You can use a dot if you want. That's perfectly fine. Do not use an X. That is one of my pet peeves here. I don't like X's anymore because obviously we have some X's in our formulas here. We don't want to use that for multiplication anymore. So we do want to multiply this out. So we have 1,400 times 5. And in this case, you could do some mental math here. It'd be 0, 0, 20, and then you'd have a 2 left over. So 5 times 1 would get you 5, plus 2 more would get you 7. So you could do some mental math here. You could also use a calculator if you need one. So we get 7,000. So this is how much I made selling 1,400. But I spent 1,160 to get here. So I need to subtract that to have my total profit. Because we don't want to include that cost as a profit. That would, throw us off. We didn't actually make $7,000. We only made $5,840 on the sandwiches. Still not bad, almost $6,000 there. But this is the profit. So really quick, I'm going to go back and I'm going to show you the graphic for the graph really quick because I have it. So here's what it looks like when we graph it. And if you notice, it says to graph this problem, we cannot use a scale of 1 as shown on this. So usually we have a graph, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing going down to negatives. So usually we can do that. But what we would need to do is make the scale at least 100 on the y-axis. And then the x-axis could stay a scale of 1. And sorry, this is a little hard to read. I know that's a really bright blue. It's kind of hurting my eyes a little bit. But if I go down, and I'm kind of guesstimating a little bit there for the 1,160. So I went down negative, and remember I'm multiplying by 100 on all these. So this is not 11, this is 1,100. Oh, I can't write on the screen. I forgot about that. Doesn't let me write on my PDFs. So this is 1,100, this is 1,200, so that's why it's right here, which is not real accurate, but it's close enough. And then I have 5 for this one, so I'd only go up 5 and over 1. Well, again, I'm going to have to work that out so that it lands somewhere nicely and I can actually put it on a point that makes sense. So if I go by 5s and I go to 60, that would take 12 times. So, because what I'm trying to do is get back to 1,100. That's why I'm going by 60. So, in order to go from this point back up to the 1,100, I'd have to go 12 slopes in a row in order to do that. So, 12 slopes in a row, and I'd have to go over here to 12 on the bottom because it's 5 over 1, which turns into 60 over 12. I'm converting it. So this is a reason why I kind of skipped over. This is not the nicest one to graph and accurately and still make a lot of sense out of it because we have such different quantities on the two pieces of the graph. So really is a little difficult to graph nicely. That was one of the reasons that I kind of X'd that off and said, no, we're just going to ignore that. But I wanted to show it to you just so you can see it. So that is the end of section 1. So I will see you in section 2.